Sounds good. Okay, so while we wait for a few more to join, Sukrit, whenever feasible, please turn on your video. Okay, while we wait for a few more people to join, any doubts from last class you want to touch on, guys? Anyone?
No, sir, nothing out here.
Prashast, okay, Prashast is fine. Did you guys go through the recording again to clarify? Arena, what did you go through the recording? Is it better after going through the recording?
Yes.
Able to understand a few more things. Okay, cool. All right. So, what about you, Sukrit? Any questions? Arsh, Sukrit? All okay. Okay, so I thought we'll just continue a little bit more on geometry, right? So we spent a lot of time on triangles, Pythagorean triplets, all of that. We also spent a lot of time in quadrilaterals, all the different types, trapezium, and from within that you have isosceles trapezium or parallelogram, and then you have rhombus, rectangle, then you have a square, then you have kite, and how all of them are related, right? So let me ask one or two quick questions to test. Okay, Prashast, first question for you. Okay, so true or false statement. Okay, listen to the question very clearly. Every rhombus is a kite. True or false? Ten seconds.
True.
True. Okay, Sukrit, do you agree or disagree? He says every rhombus is a kite is true.
Agree.
Okay, why do you agree, Sukrit?
So in a kite, the two adjacent any two adjacent sides have to be the same length, and the rhombus satisfies them.
Exactly, right? Yeah. So in a kite, you need two pairs of adjacent sides to be equal, and then rhombus, in fact, all four happen to be equal. Therefore, it becomes a special this thing. Okay. All right, Arena, question for you. A rectangle is both an isosceles trapezium and a parallelogram.
I'm sorry, can you repeat?
I'll repeat the question. A rectangle is both an isosceles trapezium and a parallelogram.
Yeah, true.
Okay. Arsh, do you agree or disagree with her?
So I agree with her.
Okay. Why do you agree, Arsh?
So, because in an isosceles trapezium, the base angles are equal, so in rectangle, the base angles are always equal because they're 90 degrees. So, hence it's true.
Okay. And then where did the parallelogram connection come?
So what?
Okay. Arena, what was the question? Can you repeat the question?
Is a rectangle both a rhombus and an isosceles trapezium and
Parallelogram.
parallel.
Okay. So Arsh, so you should answer both parts, right? So rectangle is an isosceles trapezium. Agreed. Why is a rectangle a parallelogram?
So because a parallelogram is a shape where the opposite sides are equal. So in a rectangle, are parallel. Sorry. So in a rectangle, also the opposite sides are parallel.
Okay. All right. Sounds good. Next question for Sukrit. A polygon has 35 diagonals. What would be the name of this polygon?
Sir, so the equation for number of diagonals is n into n plus 3 by 2, right?
You tell me.
Sir, I don't remember.
Okay, good that you forgot. Can you derive it? How did we derive that? Yeah.
Each vertex can go to n minus 3 other vertical. Let's say that n is the number of vertices, so it can go to n minus 3 vertices, and each one can go, and but then let's say A goes to B, but then B can't go to A, so you divide it by 2. So
very good. Therefore, the formula becomes
n into n plus 3 by 2.
And you
N
said,
minus 3. N minus
exactly. That was a mistake you said. But you derived it correctly. Even though you forgot the formula, I'm very happy that you're able to derive it. That's what happens.
Wait. So which formula was this again?
Then you tell me which formula is this, Prashast? What does this
Can I
envelope look like? This is the number of diagonals in an n-sided polygon.
So I didn't do this last class. I don't know if we did this.
Oh, we did not do this? I thought we should
Yes,
have
sir,
done
we
this.
did.
Okay. Okay, Arjun is also on. Arjun, please turn on the video. Okay, so from each vertex, right, if you have an n-sided polygon, right, if you have an n-sided polygon like
So
this.
isn't a vertex the point where like three sides are joined?
Not 3, 2.
Oh,
Yeah. Any 2 points you intersect, it's a vertex, right? The polygon has, if a polygon has n sides, it will also have n vertices. Okay, I'm sorry if this was not done. Maybe since there are 2 batches for AMC8, there might be 1 or 2 few things which I would have mentioned in one, not in the other. I say.
Yes, sir. And how exactly did we derive this? Ye kahan se aaya? Where did it come from?
Okay, so in fact, I'm very happy that Sukrit was able to derive this. So, okay, what he's telling is there are, let's say, n sides. In this case, in the example, n is equal to 6. It could be anything, 1, 2, 3, 4, 5, 6 in this example, right? But
And
any
sir,
n.
why? Wait, so why only -3?
I'll tell you.
And-
I'll tell you. I'm coming to that. Okay, so let's say there are n vertices. Let's say 1, 2, 3, 4, and so on. And let's say this finishes at n. I mean, in this case, we know n is 6, but in general, let's say it's a large polygon. You have n vertices, right? Now, if I take any one vertex, for example, vertex number 2, then I cannot draw a diagonal from 2 to 2 itself. I cannot draw a diagonal from 2 to 3. I cannot draw a diagonal from 2 to 1. So as far as 2 is concerned, you can draw n minus 3 diagonals originating from 2 because there are a total of n vertices. Okay, does this make sense, Prashast?
Yes.
Okay, and the same applies when you go to, if I count from 3, the same thing. 3 you cannot draw a diagonal to 3 to 3. You cannot draw 3 to 4. You cannot draw 3 to 2. So you can only draw n minus 3 from the vertex.
Okay,
3.
and so therefore we multiplied by n because like the vertices and yes, so that I got. Why are we dividing it by 2 then?
You tell me why are we dividing by 2? Can you guys think? And tell me why, except Sukrit, of course, because he derived the formula. Okay, Prashast, are you able to tell me? In fact, no, Prashast, you've been answering for a bit. Arsh, can you tell me why we are dividing by 2 to count the number of diagonals?
Yes, sir. So I
No.
So can I think for some while?
Yes, so think for some more time.
I didn't understand this.
Okay, you understood n minus 3 times n, that much you got, Arena? Okay, so from each vertex, you're able to draw n minus 3 diagonals. That you agree? And then the same happens if you go from each vertex, it's n minus 3, n minus 3, n minus 3. So there are n times n minus 3 number of diagonals. Do you agree so far?
So why did you multiply it by n?
Because from each vertex, you can draw n minus 3.
From each one.
Okay, so in fact, let me just draw a bigger polygon. So let's say it's a polygon of whatever, so many number of sides, let's say, right? Okay, so this is, I'll label the vertex 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there are 9 vertices in this case, correct? You don't have to raise your hand pressures. Don't worry. I'll make sure everyone gets a chance. Don't worry. Okay,
Oh,
right.
so you got it why we multiplied it by 9.
Does it
And
make sense, Arena, why I'm multiplying by n? So let's say, yeah, understood, right? From each one of them, so in this case, n equal to 9. From each vertex, you can draw 6 diagonals.
yeah, so
right?
let's
So
multiply
6.
by 6.
Now, the only question is, then it should be n minus 3 times n, right? But the formula is n minus 3 into n divide by 2.
So I
Arsh,
got the
go ahead.
answer.
Go
So
ahead,
it
yeah.
was like, supposingly if we draw from 1 to 9, and then if
From
there's
1 to 9, you cannot.
next
1 to
day-
9, you cannot. Some other
Sorry,
example.
I mean like if I draw from 1 to 7th, and
Yeah.
then I can from 7th I assume it as 7 to 1, but then it'll get repeated twice. So that'll happen in each case.
Exactly,
times.
yes.
So we divided by 2.
Exactly. So whenever you see generally divide by 2, one thing you should suspect is double counting, right? Arena, does it make sense why you are dividing by 2? 1 to 6 is same as diagonal as 6 to 1, but you're getting counted twice. Okay, right. So now back to the original question. Arjun, I asked Sukrit, but anyway, since you joined a little late. So the number of diagonals in a polygon is number of diagonals in a polygon is 35. What is the name of this polygon?
Let me think.
Sorry, say that again, Arjun.
Sir, let me just think.
Yes, yes. Yeah. Decagon. Okay, Sukrit, do you agree?
Yes, sir.
So essentially, we are solving this to be 35, which means n into n minus 3 must be 70, which means product of two numbers which are separated by 3 should be 70. And it doesn't take too long to guess, it's 10 times 7. Does it make sense? Okay, all right. Next question. Who else do we have in the class? A few more have joined, I think. Okay, Vanya, turn on your video. Whoever joins,
Yeah.
please. I cannot
So
see you.
actually, so I'm in the car. I'll go home and turn on my video.
Okay, all right, but you are able to pay attention and all that, right? So the next question is
Yes,
coming
sir.
to you. Okay, but and you have a notebook and pen where you can write and still do this, right?
Yes, sir. I'll reach in 2 minutes.
Okay, fine. All right. So I won't give it to you then. I'll give it to someone else then. Okay, yeah. Okay, first I'll state the question and then I'll decide who to give it to. Okay, so there is a n-sided regular polygon. I have an n-sided regular polygon. Okay, so the ratio of the internal angle to external angle, right? The internal angle to external angle is 5:1. Okay. Now the question is, find the number of diagonals in this polygon.
So can you repeat the question? What did you say about 5:1?
The I upon E. I stands for each internal angle. E stands for each external angle. So the ratio of each internal angle to external angle is 5:1. Okay. Now you have to tell me, find the number of diagonals in this polygon. Okay, all of you do it. Don't call out anyone. Precious, especially you have.
my answer in chat.
Okay, you sent my answer in the chat. Very good. Find the number of diagonals in the polygon is the question.
Wait, so I'm thinking. So like a shape with 5:1 and 5 interior angles is to every 1 exterior angle.
No, number of interior and number of exterior angles will always be the same, right? Is the degree measure of the internal to the degree measure of the external is 5:1.
Degree. Oh, okay.
So I had a question. The sum of angles in any polygon is equal to 360, or can it be more or less?
Some of the say that again.
Sum of the angles in any polygon can
Yeah.
be is equal to 360, or can it vary? I mean,
We did that, right? The sum of interior angles it is 180 times n minus 2, and sum of exterior angles was 360. Did we not do that? You remember? Sum of all the exterior angles is 360. I remember doing this. Precious, do you remember this? Sum of interior angles and sum of exterior angles in the very first class.
No, so we didn't do this, sir.
so
Okay.
we didn't do this as
No.
well.
Then it's not in my notes.
Of course, we should have done this, right? So all the interior angles, when you add up in any n-sided polygon, is 180 times n minus 2. Sum of
Why?
all the interior
So
angles.
how does this work? Where does this come from?
Okay, and sum of exterior angles is 360. Okay, so are you guys sure that we didn't do this? I'm very certain we did this in the very first class.
So we haven't done this.
You have not done this? Okay, all right. So if I take an n-sided polygon, so let's say again, let's consider this polygon that I have it here, right? The one that I've drawn here at the bottom. Or I'll draw a fresh one. It's easier. I'll draw a fresh one.
And so what does n mean in this? Like,
N is the number of sides.
okay.
N is the number of sides. So first I'll draw some irregular polygon. Doesn't have to be regular, means all the sides and all the angles are equal. So in this case, I'll draw something which is not necessarily regular, right? So something like this. Okay. So this is a whatever number of sides this has, right? Now, if you count the total internal angles are what? The sum of these internal angles. This angle, this angle, this angle, this angle, and this angle, and so on. Right? If I have to add all of these, what is it equal to? Let's derive, right? So if I have so many sides, let's one in this case, so many vertices, 3, 4, 5, 6 again. Okay, I can start to draw triangles. Let's say from 1 to 3, I start with 1. The first triangle I can draw is from 1 to 3. The second triangle I can draw is from 1 to 5. 1 to 4, sorry. The next triangle I can draw is 1 to 5. And that's it. That's the last triangle, correct? So counting from 1, okay, counting from 1 being the common vertex in all of these triangles, the very first one is 1 plus 2. So this number 3 is nothing but 1 plus 2, correct? So this is where the first triangle ends, correct? The first triangle ends in 1 plus 2. The last triangle ends in, this is n, right? In general, in this case it's 6, but it's n. In fact, forget this 1 plus 2. It'll always, the very first triangle will end in 3. The very last triangle will end in 6. Do you agree? In this case, n. Sorry, in this case, 6. In general, n. Okay, so how many triangles do we have? 3, 4, 5, 6. There are 4 triangles. Why? Because the ending can be in 6, ending can be in 5, ending can be in 4, or ending can be in 3. So the ending cannot be in 2 or ending cannot be in 1, because the very first triangle itself is the triangle 1, 2, 3. So there are 6 minus 2, 4 triangles. Or more generally, if there are n vertices, there will be n minus 2 triangles. You guys agree? So does this make sense to you? All of you okay on this?
Yes.
Okay. And therefore, now what is the measure of the sum of angles in each of them?
180.
So 180. And if you look at any particular angle, let's say the angle at 1. So effectively, it will get counted in one of these triangles anyway. So totally
180 and minus 2.
exactly 180 times n minus 2. So every
So
angle,
I didn't get 180 and minus 2. How do we get the 180?
because in each triangle, the angles add up to 180, 180, 180. And if I add up all of these angles, so some of these angles, for example, this angle is contributing some part here and some part here. Doesn't matter. It could be, right? Effectively, the sum of all the internal angles will be sum of all of these angles marked with the X, correct? Are you with me? And that's exactly what we are seeking, right? We are seeking the sum of all the internal angles.
So then why are we multiplying it by n minus 2, which is the number of triangles?
Correct. There are n minus 2 triangles. In each triangle, the angles add up to 180. And if I add all of these angles in the triangles, they add up to effectively the internal angles in the big
Okay,
polygon.
got it.
Does it make sense? Yeah, Arjun, you're with me as well, right? Arjun, you're paying attention here? Arjun, are you able to hear me, Arjun?
Yes.
Oh, okay, cool. So I have trouble. You're watching somewhere there, but you're paying attention here. Maybe your monitor is that side. Okay, cool. So you're with me, right? N minus 2 triangles, Arjun.
Yes.
And therefore, it's 180 times n minus 2 is the sum of all the interior angles.
Yes.
Sum of all it. Okay, fine. Sum of all interior angles. You can mute. Okay. Now, similarly, let's try to analyze what's the sum of all the exterior angles. So what's an exterior angle? So I can go to any vertex and extend one of these sides. If I extend this side, okay. Now this angle becomes the exterior angle. This angle becomes the exterior angle. Exterior angle. Okay. Now, similarly, okay. So one common mistake people do is they assume this entire thing is exterior angle. No, that's not right. So that's the entire thing is not an exterior angle. Exterior angle is got by extending one of our sides. And then whatever remains balance, that is the exterior angle. Okay, now does it make sense?
So
Harsh, you're
but then
okay?
it could be on either side, right? Like,
Meaning I could extend this or I could extend that. Yes.
so like supposingly like you extended one from like 1 to 3 ka side.
Correct.
Then you can have on like 3 to 4 ka side bhi angle and 3 to 2 ka side bhi angle.
Correct. For example, at this junction, you're saying, why can't we extend this way and we count this as the exterior angle? Correct? That's your question. Correct?
Yes, sir.
Yes. Yes, both are exterior angles, and at each vertex, both of these exterior angles will be vertically opposite angles. They'll be equal.
Oh,
Okay, very good question. So he's basically saying, why does the extension happen to have one way? It can be extended the other way also. Whichever way you extend, do it consistently. That's all I'm saying. So let's say we go anti-clockwise. So I'll erase this. Anti-clockwise, we are extending. So at each vertex, we are extending. So in this case, 1 to 2, I'm extending. Now 2 to 3, I'm extending. 3 to 4, let me extend again. So 3 to 4, that line I'm extending again. 4 to 5, I'm extending again. 5 to 6, I'm extending again. And 6 to 1, I'm extending again. I do all of these. And then I count all of these external angles. So this is, let's say, external 1, or right. I'm just calling this, let me just call it external 2. So that it's external 3. This is the external angle at 4. This is the external angle at 5. This is external angle at 6. This is external angle at 1. Now, when I add up all of these 6 external angles, what will I get? What will I get, you think, Prashast?
360.
Okay, why 360? Yes, whoever answered 360, I don't know whose voice that was. I was not paying attention. Arena, yeah. Go ahead. Why 360?
Because you are adding all the exterior angles, and since I don't know how to like properly define it,
Yeah, that's fine.
but
Just intuitively, just tell me. You're right. It's 360 degrees. But can you try one more time? Why is it 360?
because all the exterior angles are like the remainings of the interior ones, and I don't know how to explain. I'm sorry.
No. You're doing a great job. Okay. So yes, you're right on the spot. There are 2 ways to look at it, right? What she's saying is in each vertex, there's an interior angle, there's an exterior angle. In fact, let me call this I1. Okay, I'll erase all these triangles in between so that they're not distracting. Now that we agree, the triangles are all adding up to 180, 180, 180. I'll erase all these triangles. So this clutter goes away. Okay, so I'll just focus on each internal angle and each external angle. Okay, so let me just call all the internal angles in red. So this is I2, I3, I4, I5, I6, and I1. Okay, now we all agreed that all the interior angles I1 plus I2 all the way till I suffix n was 180 times n minus 2. That we agree, correct? We derived in the previous step. Now I'm asking for a formula for all the sum of all the exterior angles, E1 plus E2 plus E3, so on. So this we don't know. But let's try to add both of them. So let's try to add this way, right? The sum. Okay. Now let me just sum it up this way. What is E1 plus I1? What is E1 plus I1? Vanya, what is E1 plus I1?
So 180.
180, right? So every pair E2 plus I2 is also 180 because every pair is at that junction, right? So you have n times 180. So the sum of the interior and exterior angle everywhere is 180 times n. Are you guys all with me so far?
yes, sir.
Okay, and therefore now I can find out the question mark very easily. It's nothing but the question mark is the 180n, which is the sum of the interiors and the exteriors, minus the sum of all the interiors, which is 180 times n minus 2. So this becomes, if I take 180 common outside, so within brackets, it's n minus 2.
So can you repeat this calculation which you did?
I'm just doing a simple subtraction between the black and the red to arrive at the green. The black is all, the red is only the interiors, the green is just the exteriors.
Oh, okay, okay. It's a negative green.
And therefore this becomes 180 times 2, which is 360.
Wait, so can you repeat once? Sir, I didn't get it.
I'm not going to repeat. I'm going to ask someone else to repeat, and that someone will be, let's see, Arjun. Can you repeat how we derive this?
Yes.
Yes, go ahead.
Sir, so basically, all of the I1, which are the interior angles, as they add up, we take it as 180 into n minus 2.
Sir, I can't hear.
Yeah, we cannot hear. Arjun, you need to speak into the mic, please.
So can you hear now?
Much better, yes.
So
And you're explaining this to Prashast. So make sure Prashast gets it. So that's your job.
yes,
Okay.
sir.
Pause where needed.
So I1 till IN is what we're adding, and those are the interior angles. So we took it as 180 into n minus 2.
We did not take it as 180 and 10 minutes. So we derived it to be 180 times n minus
We
2.
already derived it. So
Pause there for a second. Prashast, you agree with that?
So that I got 180 into n minus 2. That I got. I
Okay.
will find it here.
Allow him to finish. Okay. So that you agree. Continue, Arjun. You're doing a good job. Continue, Arjun.
so E1, E2, these are the exterior angles. So we have to figure out the exterior angles, like a general formula for the exterior angles.
The sum
when
of the
we-
exterior angles.
Yes, sir. So when we add these angles, according to the diagram you've drawn, so when we extend the sides of the polygon, the exterior angle and the interior, each exterior and each interior angle adds up to 180 here.
Pause there.
So,
Prashast, do you agree on that?
He said each exterior angle and all the interior angles add up to 180.
I
Each
said
exterior and
exterior
each
angle
interior.
and each interior angle adds up to 180.
Do you agree?
Wait, so each interior angle and its corresponding exterior angle
Correct.
will add up to 180, correct? Because linear pair, correct?
Correct. That's how we arrived at this entire black row, right? 180 plus 180 plus 180, so on.
So
You agree,
yeah, so
Prashant?
it will be 180 into n. Yeah, but
Correct.
why are we subtracting it from 180 n minus 2?
To
You tell
find the
me.
exterior angles.
What?
So 180 n is the total sum of interior and the exterior angles. So here we want to find the sum of the exterior angles. So we subtract.
Acha, so
out
then
the
we'll
interior
subtract it and we'll get it. Okay, got it. Just wait a second. I'll write.
Does it make sense? Yeah, well explained, Arjun. Yes. Okay. So yes, therefore it's 180 times 2, which is 360. Any other way, Sukrit, you can explain why the sum of all the exterior angles is 360? Any other way you think?
Sir, so it's a whole circle, so it will be 360.
Excellent. Yes. So what he is saying is, so let's say I start from this vertex 1. Okay. And let's say I'm looking at an arrow, right? So this arrow is tilted. Okay. Okay. Let's say initially it's at this location. Okay. Right now this arrow is at this location. Let's see how much this arrow tilts as we go through the entire sum of all the exterior angles. So first you make it tilt this much, and then you align with the red line. And then at this junction, you tilt it this much, right? And then at this junction, the arrow is tilted this much, this much, this much, this much, this much, this much.
Until it makes it
Finally, the arrow
equal.
comes back to the original location, which is 360 degrees. And therefore, the sum of all the exterior angles is 360 as well. Another way to look at it. Manya, I can see you back on the seat. Does it make sense to you?
Yes, sir.
Okay. All right. Sorry, guys. I thought this was the basic thing that I covered in the first class. Maybe, like I said, right? In different classes, maybe there are 1 or 2 things that are here and there, but overall, it'll get covered. Are we missing more people? At least missing 3 other kids today. Okay. All right. Sounds good. Now, back to the original small puzzle that I gave. So I said in an n-sided regular polygon, what is a regular polygon? Where each angle and each side are the same, right? All the angles look equal, all the sides look equal. Okay. So Kritik, you don't have to raise your hand, but okay. No one needs to raise their hand. I'll make sure I'll ask. Okay. So each interior angle to each exterior angle, the ratio is 5:1. Okay. Now for such a polygon, find the number of diagonals. Is the question clear, all of you? Okay.
Can I say the answer?
Sukrit, you can chat me the answer. You can chat me the answer.
So how to find out the diagonals? Like if you find out the interior and exterior angle, how will the diagonals come out?
Okay, so you maybe missed the previous thing. The number of diagonals in an n-sided polygon was n into n minus 3 by 2. You remember this one?
Okay.
You remember this one from before, right? But yeah, so yes, I did this in the first class. See,
So can you repeat the question, like the sum of the interior angles or the one interior angle?
doesn't matter either way. Each interior by each exterior will be the same as the sum of the interior by the sum of the exterior anyway, because it's a regular polygon. So all the interiors will be same. All the exteriors will be the same. So that ratio is 5:1. Okay, so one, yeah. I've answered your question, right? So you can connect the angles, find the number of sides, and using the number of sides, you can find the number of diagonals.
So the ratio is exterior is to interior, interior is to exterior.
What have I written here on the board?
Find the
No, here, upar.
oh, interior is to exterior. Okay.
Sir, is my answer correct?
I didn't look at your answer. Just one sec. Let me just look. Okay. Yes, sorry, Arjun. Yes, your answer is correct. And Sukrit, your answer is also correct, but you did not answer what I'm asking you. You have answered the number of sides. I'm asking number of diagonals. Okay, I'm going to give this to Vanya. Vanya, tell me.
And I'm just working it out.
Okay, sure. Yeah, Precious, you have something? Okay, I'll give another 30 seconds, guys. Then I'm going to pass it to Sukrit to answer.
So are there 54 sides or diagonals?
Correct. Vanya is right. Explain your answer, Vanya.
So first I took interior angle as 5x and exterior angle as x. So 6x is equal to 180.
Very
because
good.
sum of interior angle and exterior angle is 180.
Yes.
So then I divided it. Then x is equal to 180 by 6.
Yeah.
30.
So this is the exterior angle, right? So this is the exterior angle. This is the interior angle. Yes.
So then I use the exterior angle formula that 30 is equal to 360 by n.
Yeah.
N is equal to 360 by 30.
Very good. Which is 12.
That I use the diagonal formula, which is n into n minus 3.
By 2.
Yes. So then.
Very good. Very well explained. Yes.
So I
Does
didn't get why she divided 360 by 30. Oh,
Because the number of sides 360 by n gives the each exterior angle, right? So in this case, we know the exterior angle, therefore we are finding the number of sides. It's the reverse.
Sir, did you see the answer I sent in the chat?
After that, I didn't. One sec, I'm sorry.
so can you repeat what you said?
Yes, yes, you're right. Yeah, so you understood till the point where you got each exterior angle is 30 degree, Arsh?
Yes, so even I found that.
You found that, right? But what is each exterior angle? Isn't it 360 by n? Because there are the sum of all the exterior angles is 360 degrees.
Yes.
We saw that, right? The sum of all the exterior angles is 360. Therefore, each exterior angle becomes 360 by n.
Yes, I go. Okay.
And therefore, we can back out what n
12.
is.
12.
N is 12. And knowing that, you know the number of diagonals is n into n minus 3 by 2.
Okay. Yes, sir. This is okay.
Does it make sense?
Yes, sir.
Okay. Did we do ratio of side lengths in a 30, 60, 90 triangle?
No,
No, wait, so that is fine, but sir, I don't understand this. I don't get it.
Okay, which part, Precious?
This is the entire thing.
Okay, help me get started. So, okay, all right. So do you agree that on each exterior angle and each interior angle, they add up to 180 because of the linear pair, correct?
Yes.
And the ratio is 5:1. So let's say this is 5x, then this will be x. Do you agree?
Sir, may I go to the
No.
washroom, please?
Sir, it says it's 5:1. Interior angle is 5 times that of x.
Yeah, correct. I marked it wrong here. I'm sorry. This is I and this
Sir,
is
may I go
E.
to the washroom, please?
Yeah, please come back. Yeah. So this
Yeah.
is I and this is E. Okay. So the
Correct.
polygon is something like this. Let's say it's getting completed, something doesn't matter. So this is 5x and x. What she's doing in the very first step is because of the linear pair, this adds up to 180.
Correct. Which
And
means
therefore,
x is equal to 180. Therefore, x is equal to 30.
you
This
agree?
is fine.
But what is x? X is each exterior angle.
Huh.
And what is exterior angle? 360 by n, correct? Because the sum
Yes.
of all the exterior angles is 360. And we are saying it's a regular polygon, which means all the angles are equal. Therefore, each exterior angle becomes 360 by n.
Wait. So I didn't get this.
Okay, there are
Each
n
exterior
sides.
angle is x, which is 30.
Correct. But each exterior angle is also 360 degree by n, where n is the number of vertices or sides.
So therefore, n is equal to 360 by, 30 is equal to 360 by n.
Therefore, you can figure out n as 12.
Wait, so then we move n to the other side by multiplying it by n. So
it's-
then n into 30.
Okay, just think of it this way, right? 360 divided by what will give me 30? That's
No,
what.
so that is, so it's 12, but like technically the correct way to do it would be like multiply both sides by n
Correct. And then bring the 30 to this side.
by dividing it by 30.
That's what you're doing, right? Yeah,
So then n is equal to 360 by 30, simplify करके 12 आ गया.
correct.
Okay.
Right? And from there, you calculate the number of diagonals.
Third, the ratio of sides for a 30, 60, 90 triangle is 30 is to, is 1 is to square of 3 is to 2.
Correct, right? You remember this one, right? 1 is to square root of 1 is to root. So this is going to the next question, right? So nothing to do with this. I'm just checking you guys on what we have done in the past. So in a 30, 60, 90 triangle, just to repeat. So this is 30, 60, 90. The ratio of the side lengths is 1 is to root 3 is to 2. This is just the ratio, right? Which means this can be 1 times some k. This could be root 3 times some k. This will be 2 times k, right? You guys all recall this, right? Now, my question is not this. My question is as follows. In a rhombus, so there is a rhombus. Okay. In a rhombus. Okay, so in fact, I'll say A, B, C, D. Okay. Angle B is twice angle A. Oh, sorry, this is reverse. Angle A is twice angle B in this rhombus. Okay. Now, what I want is ratio of bigger diagonal by smaller diagonal. There are only 2 diagonals in a rhombus. I want the ratio of the bigger diagonal to the smaller diagonal. Okay, all of you work it out. I'll give some time.
So why did you give the triangle? Oh, okay.
Why did I give the triangle?
No,
Oh, no, just to recap, you'll use this information. You could use this information. You need not, but
okay.
it could be useful. Okay, so I'll just recap. Question clear to everyone, right? Arena, the question is clear to you? Yeah. Arjun, are you back from your washroom? You understood the question, right? Okay. Don't call out the answer. Whoever does it, I'll ask who will be answering. Arena, you have something? Okay. No, I thought you were looking at the. Okay. All right. Continue. Okay. Arjun, anything?
No, sir. No, I'm sure.
I'll give you guys 1 more minute, then we'll discuss. It's already been 2 minutes. If you recall all the properties of a rhombus, you should be able to do this. Okay, Sukrit, go ahead.
Sir, so since when you add both the diagonals, there's
Both angles.
four
Both angles, you mean?
both the diagonals.
Oh, both the diagonals. Okay, all right.
So it becomes a so it first I use the first I said that since the sorry, can you repeat the question?
Ratio of bigger diagonal to smaller diagonal. The length of the bigger diagonal to the length of the smaller diagonal. Sure, it's there on the screen. You're able to see, right?
Yeah. Sir, so I figured that there's 4 30 60 90 triangles.
Very good.
And then since there's 4, the first diagonal from the 120 degrees to 120 degrees is equal to 2, because for each of the things, let's just say 1x and x or 2x, and
Okay,
then
so
then
so just so that everyone is on the same page following. So he drew this diagonal and then he drew this diagonal. Okay, and then if I'm right, Sukrit, you are calling this portion as x and therefore this portion as x. Is that what you're
yes,
doing?
sir. Yeah.
Okay, all right. Continue, please. And this is okay. Hold on 1 sec. This property is because of y, Arsh. So he's saying this is x and this is also x.
So because diagonals in a rhombus bisect each other, that means divided equally.
Correct. Very good. And then he also mentioned 120 and 60. That I think was obvious, right? Because adjacent
Straight line.
angles, yes, adjacent angles in a rhombus are co-interior angles. And therefore they add up to 180. The entire A and the entire B add up to, right? So the entire A and the entire B add up to 180.
So I didn't get this. How
So,
did you get this?
In a rhombus, he said this angle and this angle add up to 180, didn't we? In the one of the properties. Opposite angles are equal and adjacent angles are supplementary in a rhombus, if you recall the properties of a rhombus.
Okay, I didn't.
Yeah, because they are co-interior angles. You remember we did all this corresponding angles
Yes,
and co-interior
yes.
angles because
Okay.
these two are
That
parallel.
we can get that.
Yeah,
Supplementary.
so these two are supplementary. And one is given to be twice the other. So let's say this is B is x, then A is 2x.
And so in a rhombus, AD is parallel to BC and AB is parallel to DC.
It's true even in a parallelogram, but yes, rhombus is a parallelogram. Okay, so that's how we are.
Wait, so now I'm confused.
Okay. Tell me, what is your confusion?
Yes. So, sir, you had said that A plus B is equal to 90 degrees. Sir, it's equal to 180 degrees, not 90 degrees.
Where did I say 90? Did I say 90? By mistake, maybe I would have said 90. I meant
So,
180.
so you said complementary.
Did I? No, they are supplementary. I said supplementary.
Acha. Okay, but फिर भी sir, एक बार sir फिर से just can you like explain this once?
Okay, sure. So we have two parallel lines. Do you agree? If you have,
Yes.
forget about rhombus. If you have two parallel lines and have a transversal, then you agree that this angle and this angle are supplementary. They are co-interior angles.
Yes, correct.
Okay.
Agreed.
And in particular, in this case, let's say P is X, then A is 2X because it's given to me twice. I said angle A is given to me twice angle B. You agree with that as well, Prashant?
Wait. एक second. So repeat once. I didn't.
I had given in the question saying angle A is twice angle B.
Correct.
Okay. Therefore, you can find out each of these angles.
So therefore, A must be 120 and B is 60.
Correct. That's exactly what I was asking Sukrit to explain. He quickly figured it out and then he moved on. I wanted him to explain to class why it was 120 and 60. Okay, continue,
Okay,
Sukrit.
yes. So can I continue from here because like I think I know how to go
Find
about
the ratio of the diagonals. Okay,
Yes.
fine. Prashant, can you continue from here? Yeah.
Yes, so I'll just go on as I think about it because we know like because like the diagonals of the rhombus like intersect and make like 90-degree angles.
Yes.
Therefore,
So which is why
all
he said
of
he
like
also
the
said these are all
four
90.
triangles inside the this particular rhombus will be 30, 60, 90 because we are dividing A into two parts, which becomes the 60, and we are dividing B into two parts, which becomes like the one becomes the 30.
Why does it
So
why does
like-
it become angle A get divided into half?
Why? No, like why? No, I don't get it. Well, what are you saying?
So in a parallelogram, does the diagonal bisect each angle?
In a
In a
parallel,
parallelogram, does the diagonal bisect the angle through which it passes?
not necessarily.
Okay, then why are you saying here it's getting divided by 2?
No,
Because
but
it's a
like
rhombus.
here, all the sides are equal.
Exactly. In a rhombus, the diagonal bisects the angle. In a general parallelogram, it's not. So it's not a property of a general parallelogram. It's a specific property of a rhombus that the diagonal will bisect the angle. So it becomes 60. Right? Continue, Prashant. Actually, no, hold on one sec. So you had some more chance, right? I'm going to pass it to Vanya from here. No, Arena, can you continue from here? So far you're with me, Arena. So far with us, whoever has walked us till this point.
Kind of, but I was just gonna ask one a question.
Tell me.
How exactly do you like get the like the angles? Like how do you know? Like how do you make the base of the entire?
Yeah, so we don't know what the angles are, but we know that the sum of the co-interior angles is 180. In this case, the two adjacent angles in a rhombus, the entire angle A and the entire angle B add up to 180. Did we not see this? And then we saw one was twice the other. Therefore, we said 3x equal to 180, therefore x equal to 60. Does it make sense, Arena? I'm not able to hear you full. You're on mute.
I'm a little confused.
Okay, so do you agree that A is twice B because that is given in the question? Do you also agree they add up to 180? A and B, entire angle A and entire angle B.
Yeah, but the total is supposed to be 360, right?
That's sum of all the four angles. I'm specifically talking about angle A plus angle B. Because they are co-interior angles, right? So let's say this is A, this is B, this is C, and this is D. Specifically, angle A and angle B add up to 180, right? Yeah. So knowing that, you can figure out angle B and angle A separately as 60 and 120.
Oh, okay.
Does it make sense?
Yeah.
Okay. And now Prashant further broke it down using the diagonals. He said the diagonals bisect the angles in a rhombus. And also Sukrit said each angle, the diagonals also intersect at 90 degrees. So it recaps a lot of these properties of a rhombus. Okay. Does it make sense, Arina, so far?
Yeah, I think so.
All right. I'll let Vanya complete it now. Okay. So now Vanya, you want to take it from here?
So I didn't understand. Like I understand what you told, but I
Okay.
thought
Fine. I'll give it back to Sukrit. Sukrit, continue.
So since in each 30, 60, 90 triangle, the ratios of the sides are 1 is to root of 3 is to 2, the let's say the intersecting point is E, right? It's
Yeah, I've
written E,
given the
right?
intersection point as E. Correct. Yes.
So DE is equal to uh, root of 3x.
Yeah, root 3 into x, because you have to maintain the ratios 1 is to root 3 is to 2.
So how did he get
So,
this?
so the ratios of the
Hold on 1 sec. Arshi is asking, how did you get this? Explain that, Sukrit.
so I don't remember how we derived it in the class, but
No,
I
he's,
remember.
he's not even asking that. Arsh, you agree that this is a 30, 60, 90? This is a 30, 60, 90.
Yes, sir.
AED is a 30, 60, 90 triangle. And any 30, 60, 90, the ratio of the side lengths is 1 is to root 3 is to 2. You remember, we recapped that formula just before doing this question. The one opposite to 30 degrees is the smallest. The one opposite to 60 is the medium. And the one opposite to the 90, the hypotenuse, is the longest.
Oh, yes.
That ratio is 1 is to root 3 is to 2. And
Yes.
that's exactly what he's doing here. He's
Oh.
saying this is x, this is root 3x. Continue, Sukrit.
Sir, so the ratios between the diagonals will be 2 is to root 6.
Yeah. So in fact, I'm asking the bigger diagonal to the smaller diagonal. So it's 2 times root 3 times x upon just 2 times x. Therefore, the ratio just becomes root 3 is to 1 or just root 3. Does it make sense to everyone? Prashant, this is clear to you?
So can you repeat?
So I wrote it in the chat. I even sent it that answers.
Okay. Sounds good. Good.
You
The
could-
answer is root 3 is to 1. Yes. Vanya, I'll just repeat the last steps. You're with me till this step, right? This is x is to root 3x.
Mm.
Okay. And ratio of the two diagonals means what? I wanted BD upon AC. But BD is nothing but twice root 3x. And AC is nothing but twice x. And therefore, the ratio is just root 3 is to 1. Does it make sense?
Yes, sir.
Okay. All right. So let's move on. So I want to do a few properties of circles as well today. Okay, so we covered triangles and quadrilaterals in detail. So the first basic property in circle, let me just draw a circle here, is, okay, first let's define some basic terms. So center, all of us know. Okay, so center, all of us know. Oops. Let's say this is C, right? Now, if I draw some straight line here, from here to here, so dividing it up into 2 parts, right? So this is A, this is B. Okay, so this is called the minor segment. Minor segment.
So I thought it's called a chord.
AB is a chord, but this AB is a minor segment. So this,
Okay.
so the arc portion of it, okay, is called the minor segment, and the other bigger portion is called the major segment. So this portion, which looks very ugly, right? I don't want to draw that. So the entire portion from here all the way till here, that's the major segment. Okay, so both are AB. But the question when I put AB is, are we going upwards? I mean, are we going the longer route or the shorter route? So depending on that, one is the major segment and minor segment. Okay, and yes, as he rightly said, if you look at the line segment AB itself, that's called the chord. Okay, all of us know this. Now, if I join to the center of the circle, right? A and B. So C to A and C to B. Okay. Now, this portion that forms like a hat of a clown or something, right? This is a sector. Right? A sector has an angle at the center, right? Let's say this is theta. Okay, and then you can find the area of the sector very easily. It's just theta upon 360 because the fraction of the circle it's occupying is 3.
So what's theta?
Theta is the angle.
Oh,
The angle. Oh, this, you have seen the Greek letter theta, right?
Yes.
yes.
Right? So like with common angles that are used are alpha, beta, gamma, delta. Okay, so there's like A, B, C, D roughly. And then there's theta, and then there's phi. It's pronounced like the number phi. Some people call it phi. Okay, so these
Wait,
are
isn't phi that trident looking thing, like that cup?
okay. So
with
this
the-
is
Yes.
phi. This is
Oh, this
phi,
is
psi,
psi.
and this is phi.
So
And this
there's
is
basically,
theta.
and so like, what about the zero with a diagonal line in it?
Like this. Oh, no. Oh, you mean, oh, this is phi. So this is phi and this is psi.
No, like a circle with a diagonal line coming through it.
That's what I've drawn. This is phi.
No,
This one, right?
diagonal line. Like,
Oh, you mean like this?
no, like diagonal.
Like this, you mean?
Huh.
Yeah, this is what typically is theta, right? Theta is generally put like this. Some
Yeah,
people,
exactly.
while putting it, maybe sometimes they will maybe put it like this, but they're all roughly
Okay.
theta, you can just say, right? So it's okay. Okay, now back to this question. So if the center angle is theta, the area of the sector becomes theta upon 360 times pi r square. Since the area of the entire circle is pi r square, and this is occupying a fraction which is theta upon 360. Okay, so that's a sector, right?
Wait,
Now,
so this into pi r squared is the area.
correct.
Why, sir? Why only pi r squared?
Because pi r square is the area of the entire circle.
Correct.
This is the proportion of this entire circle that this sector is occupying is theta upon 360, right? Let's say theta is
Acha, and this is the area of the sector.
correct. Area of the sector. That's what I've marked. Yeah,
And
Arena.
why pi? Why that one specific number? Why not anything else?
No, because the area of the entire circle is pi r square, right?
No, I'm just talking about pi. Why only pi 1? Why can't it be any other number? Why only pi?
So that's like asking why is the area of the circle itself pi r square?
Yeah, exactly.
Okay, so that's a separate derivation. Assuming the area of the circle is pi r square, this is just a fraction of pi r square. That you agree, Prashant? Okay, so that's the fraction that we're talking about. Arena, your question?
I wasn't understanding like the symbols, like theta and all that.
Okay, don't worry. So just know a few basic alpha, beta, gamma. This you would have seen. These are all Greek letters. Have you seen this alpha, beta, gamma? Or maybe you see it now. Okay, this is equivalent to your A and B and C. And I don't know what theta is equal to. Maybe T, I think. I don't know. It does not have to have direct correspondence with the English alphabet. But these Greek symbols are used typically to represent angles in geometry. The common ones being alpha, beta, gamma, and theta. Yeah, Rena, makes sense? Okay, all right. So that's a sector. Now, when I say segment, I said there are ways to look at the segment. One is the arc itself, right? That's also called a segment. And sometimes this section is also called the segment. So depending on the context of the question, when people say the segment AB has an area of blah, 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 that means they're talking about the actual area as opposed to the arc, which is a curve. I'll repeat it again, okay? In fact, let me not even say this. I'll just say this is major arc and minor arc. That way it will be very clear. So this is the major arc AB. And this is the minor arc AB. Okay. Now, this is the major this is the area, the portion which looks like this, right? So this is the minor segment. Okay, so minor segment, which stands for this area, and the entire other big portion, right? So this one is the major segment. Make sense? Okay. All of you good so far? Vanya, you're with me?
Yes, sir.
Okay. So one important property in a triangle, in a circle, is if I touch the circle somewhere and come back. So what do I mean by that? For example, let's say from A, with the chord AB, right? If I travel till somewhere here, let's say, and then come back here. Okay. So this angle at the top will be half of theta. Okay, this angle at the top will be half of theta. Okay, let's quickly derive it. Okay, so for example, I'm just saying, let's say this is 40 degree, then this will be 20 degree. Okay, now let's quickly derive it, why this comes from. I'll draw another diagram. That way it will be a little clearer. Okay, I'll draw a bigger diagram, much bigger diagram. And then I will draw from here to here and a much bigger angle like this. Okay, now let's say this is my, and then I touch somewhere on the circle, somewhere here, let's say, and then come back here. In fact, I don't want it to show like it has to be symmetric, right? It can be somewhere here, closer here, and farther from here. Okay, now what am I saying? I'm saying if this angle here is theta, then this angle is theta by 2. But I'm just indicating, I'm not marking it so. We'll derive it. Okay. So the gray angle will be half of the angle theta at the center. All of you with me so far? Okay. But why is that? So let's try to see why it is. So from the center, let's try to connect this point from here to here. Okay. Now let's call, there are two portions here, right? Let's call this portion as, I don't know, X, and this portion as Y. Are you guys with me so far? Okay. Now, in fact, let's label all of these. So let's say this is A. Let's call we call the chord as A, right? So this is A and B, and let's say this point is C. Okay. Now, in the triangle AOC, O is the center of the circle. In the triangle AOC, it is isosceles. Why? Because the radius are same. This is equal to this. Okay. Therefore, if this is X, then this also has to be X. Okay. Arsh, you with me so far?
So can you repeat what you said?
In the triangle AOC,
Yes, sir.
OA is same as OC because it's both are radii.
Yes, sir. I know that.
And therefore, it is isosceles. Therefore, angle A also becomes X if angle C, that portion was X.
So why is it isosceles?
Because OA is same as OC, right? The two side lengths are same.
Oh, yes, sir.
Yeah, makes sense. And similarly, if I look at triangle OBC, same thing. Because that is Y, this is also Y.
Yes.
All of you with me so far? Precious, you're with me as well? Okay.
Yes, so far, yes.
So far, yes. Okay. Now, what is, if this is X and this is X, so this is 180 minus 2X. Because in the triangle AOC, all the three angles add up to 180. Similarly, this angle, in fact, I'm not going to mark the center as O. Let's assume we all know it's O. Otherwise, it's too much. Maybe I'll put it down here. So this is O. Okay. And similarly, this angle here is 180 minus 2Y. Okay. Now, at the center of the entire circle, there are three angles which add up to 360. What is that? It's 180 minus 2X plus 180 minus 2Y plus the theta. All of them form the full circular angle, which is 360 degrees. You guys agree? Arena, you agree with me? Okay, and therefore I can cancel 180 plus 180 with the 360 here. Therefore, theta becomes 2x plus 2y. Arjun, you're with me, right? So far, all good?
Yes, sir.
Okay, and therefore, if I divide by 2, theta by 2 is nothing but x plus y. And that's exactly what we started off by saying. We said this entire angle is theta by 2. This is theta by 2. Okay, so angle at the edge of a circle will be half of the angle at the center of the circle for any chord. And this is true irrespective of where you touch C and come back to B. C could be here, tomorrow C could be here, or C could be here, C could be here, C could be here. Anywhere where you touch the circle. So for example, I'll just draw one more diagram. So for example, so it could be something like this. Sorry, it doesn't draw it well. From A, I can go till here and then come back here. It'll still be theta by 2. So this will also be theta by 2.
Sir, but can the point C be below A and B?
Can the point be at the point? Very good question. It can be as close to A and as close to B, but literally at A, if it's there, then what is the angle that we are talking about? There's no angle at all, right? In such a case.
Sir, but can it be below?
Good question. Good question. Okay. I'll come to that. We'll come to that just in a second. Okay. Brilliant question. Okay. So far so good. All of you good?
Can you explain it once again?
Okay. So I'll erase all the blue lines. That way it will be clear. So we just have this. So we formed 2 triangles here. Vanya, was it Vanya who was asking? Yeah.
Yes,
Right?
sir.
Yeah. So we formed 2 triangles, AOC and BOC. And both of those triangles are isosceles because we have the side lengths as the radius. And because of that, we started off marking the initial angle as x and y at C. There are 2 parts, x and y. I'm not saying x and y are same. I'm just saying some random numbers, x and y, adding up to angle at C. Now, with that upper wala being x, the niche wala is also x. Likewise, with this y, we get this as y. And using those, we find out this the third missing angle in each of these 2 triangles. And then we completed by saying all of these 3 angles add up to 360 because they are all at the center O. And therefore, we derived that x plus y is half of theta. Does it make sense, Vanya?
Yes.
Okay. Yeah. Now, what Sukrit is asking is this. So if I have the circle, okay, I'll just draw this again. This is the center.
Sir, if you draw it under A or B, won't it become a quadrilateral?
Yeah, I'm just coming into in just a second. Yes, right. So this guy, right? So if this is theta, the one which is on the opposite side, right? So this is A, this is B, right? Is we derived that this upper wala is theta by 2. Okay. In fact, let's take some numerical example. That way it's easy that to understand. So let's say this theta looks like, I don't know, maybe looks like 140 degrees. I'll mark this as 140 degrees. Then this upper wala becomes 70 degrees. Now, what Sukrit is asking is, what about the point somewhere here? So let's say you touch here somewhere and come back to B. Right? Then what rule follows? Exact same thing, except that now we should not be looking at 70 and 140. We should be looking on the opposite side. This angle is what? 360 minus 140, which is 220 degrees. And therefore, this angle will be half of 220, which is 110 degrees. Does it make sense, Sukrit? By the same logic. Sukrit, are you with me? Sukrit, I could not hear you.
Yes, sir.
Makes sense, right? Okay, so this is 110. And yes, it forms a quadrilateral. So let's call this D, right? Such a quadrilateral, A, D, B, C. By the way, when you label a quadrilateral, When you call it out, it should be in either cyclic order or anti-cyclic order. Or I can just say A, C, B, D. Okay. But you cannot say A, B, C, D because A and B are opposite ends of the quadrilateral. Then you cannot say C, D. Doesn't make sense. Don't say it like that. Always say either clockwise or anti-clockwise. And you can always start with any point. Doesn't have to be A. I can say this is B, C, A, D. That's also fine. But you cannot crisscross. For any polygon, when you label it, that's how we should call it. Okay. Right. So the angles at the center add up to 360. And therefore, angles at the corners, being half of them, will add up to 180. And that's exactly what you're saying. 70 and 110 add up to 180. Does it make sense? And such a quadrilateral, which is snugly fitting inside a circle, is called a cyclic quadrilateral. So not all quadrilaterals have this property, right? So a quadrilateral which is inscribed in a circle, right? It's called inscribed in a circle. So cyclic quadrilateral is a quadrilateral
Which is inscribed.
Wait,
inscribed in
so can it be vice versa? Like we take a triangle and we put a like semicircle or a circle inside it. Then like what
Yes.
would we call that?
Very good. That's called a circumscribed triangle, right? So this very good question. So this inscribed and circumscribed. So it depends on which one you're talking about. In this case,
Yes, so I was just wondering because sir, I had come across this question while I was practicing. And sir, I had this problem doing it. It was an isosceles triangle.
hold on 1 sec, Precious. Let's finish this and then we'll go back to your question, right? So
Okay.
this is an inscribed. So the quadrilateral is inscribed in the circle, right? So, so back to it can be does not have to be a quadrilateral. So we have this, let's say, right? So I have this I can have a pentagon, for example. Right? So this is I can tell it in two ways. Pentagon inscribed in a circle, or you can also say in a different way the same thing. You can say and therefore which means it's a cyclic pentagon. Whenever it's inside, whenever the quadrilateral or the pentagon or any polygon is inside a circle, it's called a cyclic polygon. In this case, cyclic pentagon. But the same thing you can also say the circle circumscribing. Okay, the word circumscribing means outside. Very simply, it's outside. This means it's outside. Okay, it's another fancy word for outside. Inscribe means inside. That's it. Just fancy words. So circle circumscribing the pentagon. Right now, what Precious was asking is some other example he saw. It was something like a triangle was there, maybe, and then there was a circle which was sitting inside
No,
the
it's
triangle.
not a circle, a semicircle.
Okay, fine. Whatever. If it's a semicircle, then you cannot say it's. You can say the semicircle is inscribed within the triangle. You can say that.
Okay.
Right.
Okay.
Again,
Yes, sir.
right. So again, you can, depending on which is where, you have to use the words accordingly. Right.
Yes,
So
so I just had this problem solving it. So sir, I thought that maybe you could help. Like there was an isosceles triangle.
okay. Rather than can you paste the picture on
Yes.
the group or something? Maybe it'll be easier. You don't have to do it right now. You can do it later also. Okay. Let me cover the main properties that we need to talk about, right? And then you can put that question whenever it's feasible, right? Is that okay, Precious? Okay.
Yes.
All right. Sounds good. Right. So now the main thing that we saw was the angle at the center is twice the angle at the circumference. That's the number one. The other important property, of course, is if I have a circle and if I draw a line segment from the center of the circle to the midpoint of the chord. So this is a chord. So this is AB, this is a chord. So let's say the midpoint of the chord AB is M, right? So if I connect from the center Okay, so this is the midpoint. So this is the midpoint. Then this will be perpendicular. So if we draw something which is from the center O, if I draw to the midpoint of AB, it will turn out to be perpendicular to AB as well. And that's something very easily can be proved, right? So for example, if I have OA and OB, you can see very easily that these two triangles are congruent. Why are they congruent? Because OA is same as OB. Okay. OM is the common side. And AM equal to PM. So by the SSS property, right? Banya, you remember the SSS property, right? For congruence? Banya?
Yes, sir.
Okay. So the three sides in AOM are correspondingly equal to the three sides in BOM. Therefore, by SSS property, the two triangles are congruent. And therefore, this angle must be equal to this angle. But together, they add up to 180, we know. And therefore, each has to be 90. Right? Therefore, from the chord, from the center, if I draw to a midpoint of the chord, it's actually perpendicular to the chord. And likewise, you can tell it in a reverse way also. From the center, if I drop a perpendicular to the chord, it divides the chord into two equal halves. Another way of saying that the perpendicular and the median are both same. Make sense? Now, right? So now one other interesting property is this. If I have a circle again, and you guys all know this much, that if I have a tangent, I'll just use another color. If I have a tangent,
So what's a tangent?
a tangent is just grazing through the circle at this point. A tangent is a line which just grazes through the circle. You can just say it just tangentially went through, which means it just touched the circle and went. It's called a tangent. Okay, so if this is a center of the circle, this is the center of the circle here. Okay, so if I connect the center to the point of tangency, then this angle will be 90 degrees. You guys know this? You would have studied this, right?
Yeah. So that's exactly what my question was about. So why would it be 90 degrees?
Okay, because that's the closest point on PQ. That's the closest point, right? Right. So this is, let's say this is M. So CMQ, which is the isosceles triangle you're talking about, Precious, in your question?
Sir, I was just saying that it's an isosceles triangle with the two sides that are supposed to be equal as 17 and the base is 16 and the height as 15. So then I automatically concluded that if we divide it into two congruent triangles, it will be 18, 15, 17 Pythagorean triplet. And the question was find out the radius. But I was not able to figure, like,
Okay.
I was not able to go beyond the Pythagorean triplet.
Okay, so given he's asking about this question, so basically I'll just, if I can recall what you're saying, let's say you have an isosceles triangle, like 17, and what is the other side?
17, 17, 16.
17, 17 and 16. Okay, so let's draw it that way. So this is 17. So this is 17. This is also 17.
And the base is 16.
Base is 16.
Correct.
Okay. Okay. All right. So let's say this is my A, this is my B, and this is my C. Since it's isosceles, it's symmetric. And therefore, if I divide the base into two equal halves as 8 and 8, okay, this is 17 and this is 17. So if I connect
And the
this,
height is 15. The height is 15. That's also given.
that need not be given. That's what I'm saying. The height need not even be given. We can figure out it's 15 because if I draw till the midpoint of BC, okay, let's say this is M, then by the same logic that I just said, that these two triangles are similar or congruent. I'm sorry, congruent, because I know this is equal to this. I know this is equal to this. And then I know this is a common side. Therefore, by SSS,
So by SSS rule, the triangles are congruent.
congruent.
So
And
SSS rule.
SSS rule, the congruency of triangles. Have you studied congruency of triangles, Arsh?
So I don't remember it clearly, but I've
So
studied.
sir, I've just studied it, so that's why it's still in my mind. So
Okay.
that's why I still remember this.
Okay.
Yes, sir. And now there's a semicircle inscribed
No, no,
in.
one sec. Precious, you need to give everyone chance to talk, right? Okay, I'm just clarifying something for Arsh. So I know you're eager to share a few things, but please hold on. Okay, so Arsh, congruency is whenever I have triangles, right? When you say the two triangles are congruent, it means you can just replace one with the other. You can just lift it and put it in the other. So there are many ways in which you can say two triangles are congruent. So I urge you to read up a little bit. I'm sure this is basic school stuff. So if I have two triangles where the sides correspondingly are equal, right? As in this case, right? The two sides are given to be equal, 17 and 17. The two base angles, the two base parts are same because I've joined it to the midpoint. And then the third side, AM, is common. Therefore, by SSS, the two triangles are congruent.
The
Which means
third side
what?
will also be equal.
Third side is also, it's already equal, right? AM is the common side, right? Therefore, the two triangles by the property of SSS, meaning the sides correspondingly are equal. The side 1, side 2, and side 3 are correspondingly equal. Therefore, the two triangles are congruent, meaning all the three angles and all the three sides correspondingly will match. Correct. And therefore, this angle here will match this angle here. But we know they add up to 180, and therefore each has to be 90. Does it make sense? Okay. Now, Precious was saying, in addition, this height AM was given, but AM need not be given. I'm saying we can derive AM because in the triangle AMB, it's a right angle triangle. And we saw one of the triplets was 17, 8, and 15. But if you don't remember, that's fine. 17 square is 289. And then 8 square is 64. If I subtract the 2, I get 225, which is 15 square. Therefore, I can infer the height to be 15.
Yes, and sir, one more thing.
Hold on 1 second, Precious. Is this clear to everyone? This so far clear?
Yes.
Vanya, you're okay? Okay. Now, can you continue? What is the further question, Precious?
Now a semicircle is inscribed inside this triangle with M as the radius.
Okay. All right. So I'm going to draw that with M as the radius. It's inscribed. So let me just erase off all this clutter. I'll just draw a fresh picture. That way it's clear. It's a little cluttery here. Okay. So I'm just drawing a semicircle with this as the center. Something like this, Precious.
Yeah, so more or less like that.
Okay.
With
So this is just 1 second, Precious. So this is A, this is B, this is C. Okay. And this is 17. We know this is 17, the entire length. And we also know that this is 8 and this is 8. And we also know that the height AM we discovered is 15. Okay. Continue, Precious. What is the question now?
Yes. So the question was find the radius of the circle.
Find the radius of the semicircle. Okay. All right. Okay. Find radius of the semicircle.
Yes.
Okay. All right. In fact, let me give some time for everyone to think about it. It's one of the good questions. Can you all do it? I'll give you guys 1 minute to solve this question. Knowing what I've covered so far today, you should be able to do this question.
So, but how did he find that M is like it bisects A? Like, I mean, it just goes straight.
M bisects. Because M bisects A. You mean this top angle and this angle? Sorry, which one did you mean?
So I'm like, how did he find that M bisects the BC? Like, how did
No,
he?
it is given. It was given. It was a diagram where M was given to be the midpoint. It was symmetric, and the semicircle was symmetrically placed at the base.
Oh, okay.
So let me just delete the Upperwala picture so that it's not confusing. So it is given, Arsh. This diagram is given to you. As it stands, it's given to you. Now you have to figure out the radius of the semicircle. Any idea, guys? Knowing what you have covered today, you should be able to solve this. Thanks for bringing up this question, Prashant. But only one thing I would say is, after a concept is done, then bring it up, okay? So that you have the context. Okay, so I erased off the question. Okay, find radius of semicircle. Okay. Any ideas so far? Sukrit, any ideas? Or I see some chat. Prashant, have you put something? Oh, you have put the diagram in the okay, all right, fine. Let me just paste this diagram. You could have put it in the WhatsApp itself. Okay, so we have only few more minutes for class to finish. Let me just quickly go through this, right? So in fact, he has drawn this diagram here. So it's much better. Exact same diagram. Okay, let me quickly do it, given we have only 2 minutes, guys. Okay, so he wants to find the radius of this semicircle. Okay, so let's say this is the point where it's touching. Let's call this is P, this is Q, it's symmetric, doesn't matter. Okay, now let's call this portion QC as X. Then this upar wala portion AQ is 17 minus X, because the entire length is 70. We also know that if I connect M to Q, okay, that'll be perpendicular. We just saw, right?
Because of the tangent.
Because of the tangent, right? So because the circle is, because of the line AC is tangential to the semicircle, because it's just touching. In fact, it's better seen here, right? So this is just touching. So this is 90 degrees. Okay, so now let's label some of them. So we know this is the R that we have to find out. Find the radius of the semicircle, R. Okay, we also figured out in the previous step that this height was 15. This height was 15. We saw that. Remember, 17 square and 8 square, the difference was 15 square. Now we have two triangles. Which two triangles? Upar wala triangle AQM. Right? Upar wala triangle is AQM. Okay. In this, we can apply Pythagoras theorem. We can say R square plus 17 minus X whole square equal to 15 square. Right? Similarly, in the niche wala triangle is what? MQC. In the niche wala triangle MQC, that's also Pythagoras theorem we can use. R square plus X square equal to 8 square. Because MC is the hypotenuse, the bottom one.
Yes,
Are
sir,
you all-
so that's as far as I have gotten. So
Okay. Okay. All right. Is this clear to everyone, guys? All of you good so far? Arjun, you're okay so far?
So which one is a 90-degree angle?
MQ is perpendicular to AC. So this is also 90 and this is also 90. Okay. You can see that, right? Literally you can feel it. Now, let's subtract these two equations. So R square minus R square will be 0. Okay. Now 17 minus X square will be how much? 17 square, which is 289. So all of you know that A minus B whole square is A square minus 2AB plus B square. So I'll put this separately here. When I have 17 minus X whole square, it's 17 square minus 2 into 17 into X plus X square. So 289 minus 34X plus X square. I'm subtracting this, right? Minus X square. I'm subtracting first equation minus second equation. Equal to 15 square, 225, minus 8 square, which is 64. I'm subtracting off these two equations. So the middle portion is this, left, R square minus R square is 0. 17 minus x whole square minus x square is this. And then the right hand side is this. Now, x square also gets cancelled. Now it's very simple to simplify. So I have 289 minus 225 plus 64 by bringing these to this side equal to 34x. Now I can solve for x very easily. 289 minus 225 is how much? Did I get this calculation right? 289 minus 225, 64, right? So 64 plus 64, which is 128. Okay, so x is 128. If I am doing some silly mistake, spot it and let me know, guys. So any silly mistake, Prashant, you can notice so far? Any silly mistake you can notice so far, beta?
No way, सर let me double check सर, sometimes it doesn't. इसे सर ऐसे ही देखने से सर, क्योंकि आप बोल रहे हो सर कुछ तो होगा.
No, I don't know. It could be, right? I'm not intentionally making any silly mistake and asking you to spot it, but I'm just asking. Okay, let's go with this and see. So this is x equal to 17 and this is 64, I guess, right? 64 by 17. Okay, but the question is not to find x. The question is, what was the question again? Find the radius of the
Radius of the
semicircle. Radius of the semicircle. Okay.
Sir, what is x?
X is this portion, QC. You can see, right? This is x. QC is x from here to here. Yeah. Arana, you with me so far? Completely okay, right? So far? Okay. So now I know x, I can just substitute here. Therefore, r square is 8 square minus 64 by 17 whole square. Okay. Now, obviously, this is a big number. So let's try to be clever in solving this. Okay. So let's, okay, I'll stop here. So far, you're okay. All of you okay? Arana, you're okay. Vanya, Sukriti, you're okay.
So how did you get r square is equal to 8 square minus 64 by 17 square?
R square equal to 8 square minus 60. Oh, no. I just substituted it here in the second equation. I found my x as this. And then substitute it back in this equation. Yeah, you with me?
So
Okay, but the wrong thing to do now is to deal with such big numbers and do the subtraction. Instead, don't do that. So let's say r square equal to, I can take 8 square as common. I'll write this as 8 square into 8 square upon 17 square. Okay, again, all of you with me? I've not done much. I'm just manipulating it cleverly. And I'll finish it and then explain it once more. I don't want you to deal with big numbers. I can take 1 8 square common. Therefore, it becomes this. Right? So, which is nothing but 8 square times 17 square minus 8 square by 17 square. And we know that 8, 15, and 17 are triplets. Therefore, this is nothing but 15 square. I'll go over it one more time. Also, don't worry, guys. This is r square. And therefore, r is just 8 into 15 by 17. Without dealing with big numbers,
Which
I
is
found my r.
120 by 17.
Yeah. But the key is, I did not deal with big numbers like 64 square and 17 square. I used basic simplification and knowing that 8, 15, 17 is a triplet. And then I solved this. Okay. I have to go for the next class. I'm sorry, guys. I'll pause here. I'll stop here. I'm sorry. Go through the recording anyway. But if this last part is not clear, we'll do it one more time at the beginning of the next class. Okay. Go through the recording. I'm sure it'll be clear. Especially the manipulation of the numbers at the end was a little fast. But if you absorbed it, that's great. If not, don't worry. Go through the recording. You should get it. Okay. I'll end the call here.